Why does nightlight like sunrise to sunset? Oh wait. No, sunset to sunrise. Bro, if you turn this off and you turn... Dude, what time does it think it is? Oh, okay, I don't know. Anyways, okay, so what we're doing is, if you missed yesterday, the worm drive almost works. It almost works. It stalls still a little bit. So what we're going to do is, first off, I think that the angle that we have here is slightly wrong. Let me go grab a worm. I feel like we could just guess. I mean, let's see. Okay, so just to remember, yeah, so the pitch, this is just the circumference. I think this is the major. And then this is the hypotenuse. I don't know what that is. So what we want to do is we want to find this angle. So yeah, it's arctan of pitch over. But the major diameter is what? It's going to be like 35 or something. Maybe 37, 30, 38. Let's just guess 38. Does this have arctan? Oh, but that's in radians. Whatever. Okay, so this is going to be... Oh my god, startup time sucks. Arctan D. What? Atan D. There we go. Atan D of... the pitch is going to be 2 pi divided by 38. Okay, see, that seems way more correct. I don't know where I was getting the other one from. This is the pitch, and it is 2 pi. And wait, and this is the diameter. Yeah. It's not the circumference. Right? Yeah, it's not the circumference. I'm pretty sure that no, but this says pi d. But I don't think that's right. I think it's actually just d. Because if you're like unraveling this thing, yeah, so let's make it 10. So let's go to, where do we actually have the... Okay, so we're going to make 2 changes. We're going to print 2 things. So the first thing we're going to do is we're going to find Oh, and I was thinking I could also add another motor here, but the problem is I don't have the I don't have the pins. So I was thinking I need to buy this like expander Arduino, like these things that use I squared C, but it's like I kind of don't want to do that. Okay, so we want to do this, and we want to do switch to, and then we want to take this, and we want to add helical of 9.38 degrees. And honestly, should I try to make this a little bit thicker? Why don't we just experiment a little bit? Let's make it, there's no reason not to, right? Let's make it a 10. I'm going to make it a fat gear. Okay, so let's go back to, it's so hard to find anything. Is this the furthest over? What is it even called? Big bearing? So is it going to update though? There we go. And I think I want to go back to this being 33 because I don't think that was the issue. But okay, but the main thing that we're doing today is we're going to take this. And if you see here, this mass, which is the heavy part of this whole assembly, these are relatively light compared to this because this is literally just like basically a solid bar of copper, is we're going to try to move all of this maybe like 30 millimeters forward. Okay. So it's literally basically a matter of extruding this by 30 millimeters and moving all the holes down. Okay. I feel like hole patterns are something that is easily translated from natural language into code. Let's see, can we just look at this sketch? Oh, that's the wrong thing. Oh, from that line. What is constraining this is like that. So what we actually want to do is delete this. And then we want to make this like... Wait, why is this changing the... Wait, let's undo that. What is driving this? How do we know? Oh. We need to say that the... So wait, but if we move... Okay, so let's delete this again. Can we get normal to this fucking thing? Okay. So if we go down, see how it's getting bigger? But that's because we don't want it like that. We want it like... no, how do you get a... Okay, let's just do this. Let's make a construction line. Let's say D. That. And what was the number? We need to go back and remember the number. Nerf compressed over 2. Right. Okay, so we're going to make this line. It's a Q. It's here. This is Nerf compressed over 2. Okay, so now if we move this down, it just moves this down. So now what we want to do is say the distance from here to here, which way? This way is, yeah, let's just move it 30 forward. Why is this wrong? What is wrong? Wait, what? Wait, oh, because I got some weird coincident thing? Oh, jeez. Okay, that's just random nonsense. Oh, that's what happened. Okay, it was just a weird coincidence. So yeah, let's make this 30. Is that going to cause an issue anywhere? I don't think so. So let's do this. And now a bunch of stuff failed. Why is that? Well, we need to go back to this extrude, right? Where did this go? Yaw only bracket width. Let's just add 30 to it. Okay, so but we don't even really want that, do we? Because that's not right. Maybe I should just redesign this from scratch. It's not going to be that hard, right? Like, we can... Okay. So this is going to be... Okay, so basically what we want to do is extrude this by 30. So wait, when we do this extrusion, we keep it the same. Then we do all of that. Then we do that. Then we do this. Then we mirror it. That's fine. Then we fill it. Then we do this sketch. So why don't we take this extrude and move it before that sketch? Wait, is it this sketch? What's wrong? We can just do EU. Why is it wrong, though? Oh, wait. It's because this is not connected to here. What's wrong? Oh, I think it's good. I think this is just extra. Oh, wait. Is this supposed to be... Is this supposed to be this? It might be that. undo. No, I don't think so. Do I have to use this? No, I have that. Right? What is this constraint? Oh, wait. Um... No. We kind of want to keep it how it is, right? Wait, let's just I think I might be able to do it just without rebuilding it. It's a little bit of surgery. I'm going to duplicate this, and this is going to be what we're going to use. I'm going to say forward solenoid. Okay, so what we want to do is we want to extrude this by 30. I'm going to take this face and we're just going to extrude it by 30. Okay? Now, the next step is to move these forward by 30. So, but in order to do that, let's delete that. In order to do that, we need to move that. Oh, I love that you can do that. Okay, so we want to move it before this sketch. Now, in this sketch, okay, wait, can we hide it? I wish there was a way to, oh yeah, okay, so let's try to suppress. So let's suppress this, and let's look at this sketch. So this is coincident to that corner. So what we actually want to do is get this dimension. So this is 68.6. So let me just write that down. So that is, and that's a parameter actually, because that's in this extrusion, we extrude by this, yaw only bracket width. So basically what we want to do in this sketch is we want to unsuppress, and then we want to look at this, and then the distance between here and here is this thing. And we can delete this coincident, right? We still want this to be on that line. Okay, yeah. Like that. And now we just want to delete this, because I don't know why it's being weird. And then we want to say the distance between here and here is the same as this thing. Okay, now what we want to do is take this, delete this, and then we want to also draw a line. Let's see, is that? Okay, yeah. That's the midpoint. That's the midpoint. So now what we want to do, instead of this, we actually want to do this. And this is going to be nerf compressed over 2. Okay, so now we have the ability to move this forward, which is great. So what we want to do now, oh, crap. Okay, so let's move this down here. So now we want to say this to this center point that we used to have is 30. Okay, now if we rebuild this, that's great. And these holes came forward, which is nice too. So then all we have to do is to this extrude, right? We kind of only need to make it like 10, right? So, okay, so now what we want to do is go to this, and this is our main assembly. And we're going to replace instances. We're going to replace the instances of this. Wait, that's, no, tilt holder. Replace instances with big forward solenoid. I don't see anything wrong really with this. Let's do that. Let's move this. We got plenty of clearance there. Everything looks good. And we should actually, we might even be able to get a higher angle. That's pretty good. Okay, so that surgery seemed to work pretty good. So we can just print this and move on to doing something else. So we are going to take this and export it. We are also going to take that gear and export that gear. Oh, wait, can we look at these, oh, did I switch again? I always do that. Anyways, let's see. Wait, this didn't update like I wanted it to, did it? Oh, there it is. Oh, yeah, okay, wait, can we pull that in? We're going to need to pull that in. That's not going to work. Oh, crap, so we have to reprint that. Should we add it as a feature at the end, or should we change it correctly? I'm just going to do it at the end. So we need to go to... Oh, this isn't even the right document. This tilting solenoid holder. Okay. So now let's... okay, cool. So now we have some clearance there. Oh, but... no, but wait, what? Oh, did the whole... Oh, jeez. Okay. Oh, wait. Redo. Okay, so we need to go back to this. Undo that. What we're going to do is we're just going to... It's funny how things work like that, huh? Okay, cool. All right. So we just need to print 3 things. We need to print this again. We need to print the gear, and we need to print this. Okay. So let's just select those 3 things in here. Solenoid holder. And I think I am going to switch to the 33. We're going to get this, this, and this. We're going to export this. Okay. This is helical gear, reduce, move solenoid forward. Okay. Let's go to this. Please be able to do it in one thing. The only thing that needs supports should be this. Dude, it's so weird that that happens. Oh, is it 'cause of the support? I don't know. Oh wait, let's do this because we don't need this. Let's It would be cool if it was like a feature. Like you could just select features instead of this. You actually selected features. Okay, let's see. Wait, what? It didn't even listen to me. Um Oh, you can. How do you undo? I don't think it's did anything though. Oh, there you go. That's so nice. That's so freaking cool. I love that. Is this helical? Yeah, it looks helical. Okay, cool. Damn, that's a long print. Wait, let's cancel that. Should I move it farther forward? I can move it as far forward as I want. I'm just trying to think, like, this isn't all that much further forward. And all we have to do is change a single number. Why don't I make it 50? Why don't I make it 50? I want to be kind of aggressive and dial it back if... So wait, so we're trying to go to... And all we need to do is look at sketch 3 and make this. So that's 50, but this this extrude 8 also needs to be 50. And then this can just be suppressed. Wait, undo that. This can just be suppressed. Okay, let's look at it now. This is the wrong thing. Do we see any issues? I don't see any issues. So by moving this in, let's make it a variable. Tilt drone forward shift. Tilt motor forward shift. And it's going to be 50. Okay, then we can go to this. Go to this. Tilt forward shift. And then in sketch 3, tilt forward shift. So now we have a parameter that can drive that. Kind of a goofy design. Might make it a little bit harder to get to this. Just to get that down. Yeah, it will for sure. But at the same time, this might solve some of my issues. So all we need to adjust, all we need to re-export is this part, right? So we're gonna have to repaint the seams. So let's delete this, add. And then we want to do supports painting. Fill, boom, boom, boom. And it's going to give me that, wait. Oh yeah, wait, we have to actually enable this. Okay. Fuck it. We ball. I'm probably gonna run out of filament, but I should go check actually how much more filament I have. Alright, so hopefully we just resolved the problem without having to use a bigger motor or anything like that. If I can help it, I'm gonna try to put in the 33 millimeter diameter worm drive because I feel like that. I want to minimize the backlash. I mean, the backlash was really big. Just in case I did buy another stepper motor, but it's like, I don't even know where my drivers are. I don't know if it came with a pack of 2. Let's see. Oh no, it came with a pack of 5? Okay, I just gotta go find them. I don't think I fried any of them. Oh no, maybe I fried one of them. But I think I probably have 2 more. Okay, so what are we gonna do for the next 4 hours? I think maybe I should do... So, okay, so let's just talk about the future of... No, not this. The future of this. So I realized, though, that... Oh, actually? No, but, okay, hold on. It's so annoying. It's very hard to reuse features. Like, I just want the whole pattern. Like, I know that this diameter is the same. Wait, it's not exactly the same? How is that possible? Oops. Okay. So we know that this is exactly the same size. So I should be able to just use the whole pattern that I have here. Ugh. So part of the problem is, let me look at this sketch. What is this driven by? I don't see what that's driven by. Oh, it's not. So let's make this like 7. And let's make this like 5. Wait, is it 5? Yeah, it is 5. I think it is 5. Yeah. Wait, so basically, let's unhide. A big part of the issue is, though, now all of our holes need to be outside of 75 from the center, which I don't know if that's true. So that gear is... Oh my gosh, bro. So that gear is not there. So what we want to do is look at... Is it this sketch? Is it this sketch? If I click on this, it's this sketch. Okay. Oh, just barely, man. Just barely. Wait. Hold your freaking horses, though. We do depend on it for... We just added a dependency on this hole on the worm drive setup. Well, on the new brackets, basically. But we no longer have a solenoid holder here, which was the original purpose of this anyways. Wait, but also this looks wrong. Wait. Oh, no, that's... Oh, okay. Wait, which one was that? Oh, I see. Oh, but these are 100 away. Oh, okay, yeah. So there's actually what, 16? No, there's 32 holes on this thing. Okay. So we got to think about this because, yeah, we got to think about that. Right, because there's 8 times 4. So let me think. Maybe we could pull it in a little bit, right? Do we have any room to pull it in? Sort of. I mean, the thing is we need to pull it in by like 10. So it might be a little bit tricky. Let's just say that this is 10. Okay, so now this is 120. So now we can use our hole pattern and not have any issues. But I am worried about the strength of this thing because, look, you're going to put a bunch of motors on here. It's going to sag. We could just increase the I mean, I'm basically thinking about my bolt length right now. Is how long of bolts do I have? Because if I make this see, is it this? No, it's not that. It's if you look at this feature, it's this. So if we look at so we said this is 7. Oh, and we kind of actually don't want this. Oh, we don't have the bearing in yet. Okay. And the angle though, it makes it more annoying to put in bolts because then the grip on the surface. I don't know if that's actually how bolts work, but basically, if there's going to be a gap on the outer side of the nut rather. So maybe that's not ideal. We could just make it real thick. Um, We should go back to frames. Start to think about this. So I kind of switched to using 2x4s. The thing is, this is, what did I say? This is 2 feet by 2 feet. It's actually huge. Plus, I guess doing revisions on the wiring, maybe, let's see, what is 250 millimeters is like 10 inches, right? So maybe we should just do this on one. Yeah, we should just do this on one platform. So the power supply and the shooter are going to go here. This is going to get pushed back. So I'm only going to use like, well, actually, oh, and then we also need a, okay, hold on. We're also going to need to think about the constraint now that we're doing that on this length, because 1 feet might be no good. But the hopper you kind of do want to be at least as close to vertically above the neutral position of the shooter as possible. So didn't I have an assembly for this thing? Yeah, I don't know how this is going to work. Okay. The funny thing is, testing yesterday, I kind of realized I don't hate the spur gear design on the bottom as much as I thought. The only thing is that well, I don't know. Maybe I should. I mean, I should definitely do it. That is the design that I should go with. Is something more akin to this. Okay, so maybe we should just start this thing. How tall is this gonna be? If we just take, so let's see, this to this is like 90. Then let's go over to here. Wait, is it? Okay, so let's yeah, this is about the maximum angle. So let's just take the top face of this to, yeah, let's make this thing 90 degrees. Just so we have a sense of like what the absolute, so it's there to there. Whoa, really? Wait, can we look at that vector? Where is that thing? Where is it drawing the... Where is that? Oh, there it is. Oh, I wish it saved it. Okay, so it could be as tall as like 300 millimeters. So, and let's see, if we were to do this, probably even more. This is like a pretty significant upper bound. 214. So at very most 350. Wait, 350? Yeah. Realistically about 300, but I mean, oh, what is going on here? Okay. So it's going to be pretty tall. I mean, it's going to be, yeah, 12 inches tall. Wait, really? That's not that tall. That's not bad at all. I'm so tempted to just print this, but I know that that's not going to go well. I don't want to jinx it. I'm going to go see how much filament I have left, though. Just to get a sense if I'm actually going to run out. Because I feel like I will. We'll see. We will see. Okay. Let's I should just redesign this from scratch. What is this circle? I picked 6, not 8. I'm definitely gonna do 8. Okay, let's just freaking do it. So we're gonna, okay. We're just gonna call this bearing, what is it? Yaw. Okay, so, um, So how do we want this to work? It's going to be the exact same thing. I think I had a good sketch here. I feel like I'm just procrastinating, but didn't I have a good sketch here? I thought I had like a really detailed cross-sectional sketch somewhere. In any case, I think we should just get started. So let's just close this and try to start with a blank thing. So, and I want all my sketches fully defined, I think. So, actually, I want to keep this open because I do want to look at some of the things that, just how it looks. Is it this? Okay, so this is 200. Seems a little bit big, but it's the reason. Oh, you know what? I probably made it bigger so that the motor could fit on it. Okay, so yeah, so what we should do. Okay, so first off, let's just set it to 200. So we're going to keep this variable studio open, which of course I closed. Okay, so before we build the table, I actually want to just get through this. Okay, so bearing yaw is going to be by. So bearing yaw, bottom, diam. 200. Okay. Okay. Now, is the ID of those bearings 80 or 100? Let's look. 80. Okay, so bearing 80. So we need to make 3 parameters in here. Right, okay. So I don't actually know what the depth is on those. This I know is 100. No, I know what I need to do. Wait, don't I have it in Oh, I was able to copy it? I forgot how I did that. Okay, it's 10. Okay. So, so at the very least, we want to make this bearing 80 OD. Okay. But okay, wait, how did we do it the first time? Is it this? Okay, we started with this freaking bearing. Okay, now this is what we did. We made this one solid part. So, did we use? We must have done a use. But if you were to dimension this to here, you would get... What just happened? Right. Wait. Crap. Wait, which one is this? Is this fully defined? Wait, why don't we just do this? Wait. Wait, we need this. Just make this 90. And then why is this even a segment? Yeah, there's no use of that. So let's go back to here. Oh, but this angle. Is there an equal constraint there? I don't know how that... Oh, no, it's the coincident. Wait, but why? Oh, it's this? But we don't actually want it to go out that much. We don't really want the angle here. This is kind of goofy. Delete this. And we just want to delete this. Okay, what is the simplest one if we were just to redraw this? So this goes up by 5. So let's just do this. Just try to, well, I don't know the whole placement, but let's say that, okay, wait, actually what I want to do is start to reason about, okay, so what I want is a construction circle here, and this is going to be the pitch diameter of the gear. And I think we lost that in the history of this thing, did we, or is it parametric? Does this, whoa. Where is the gear though? Okay, here. Oh, that's where that circle comes from. Okay, so the pitch diameter is 84. Okay, so let's just draw an I wish you could add a little note maybe. Okay, so then we also want another circle, and this is going to be 80. Okay, so this is basically, we're doing a little cross section of, so this is going to be the gear, not the major, but the pitch. So it's going to come out to here. And And so what we want to do is we want to draw a circle that's like this. And, wait. It could be a circle. It could just be a line. From here. So that's the pitch diameter. So this is, yeah, let's just say, what if we made this 33? I don't know why. So, and we actually want a, okay, let's also do this. Wait, how is that? What? But yeah, we're gonna need, okay, so what that 5 is like a wall. So the bearing, this hugs the bearing by at least 5 more. Well, actually, no, we want all of the bearing to be covered. We don't want, because I could add the cutout. So what these angles are is basically, I'm imagining I'm going to take a fourth of a cut out of this wall. So I don't know what I think I just guessed. I don't know what angle this is. I don't know how I did this. Is it this sketch? Okay, so we did it by a basically arbitrary, because this dimension is totally, and then we project it. So yeah, so that's just like a random thing that we did. So what we could do is rotate one of the planes 45 degrees. What? The front plane by 45 degrees. Then do a revolve of 270. And then that would allow us... No, we can't do that. Wait, can we do that? No, we can't do that. Because we need the rest of the thing. We can't... I mean, we could build this up one by one, but like, it's so efficient to do the front cross section and revolve as opposed to like building this up like from the top plane. But that's effectively what we're doing right now. Okay, so what I'm going to do, now that I have an idea, we're going to first draw a construction line. Or wait, no, let's just draw a line from here to here. The distance from here to here is going to be the bearing, 80, bearing 80, OD. This is going to be, oh wait. And this is going to be okay. Now what we're going to do is we're going to draw a line vertically here. This is going to be wall. It's going to come into let's see. So if we were to draw a cross section of the okay. So yeah, so why don't we do this? Wait, oh. Okay, so then that gets revolved. So I don't really get what the purpose of this angle was. I think it's just strength. But we're gonna go weak. Yeah, I feel like build the weak thing first just to see if it actually does break, because it's like premature optimization. It's like you just don't really know. So then this just needs to go up by however much, right? So we're going to delete this segment. And this, we have some weird coincident things. So we need to delete this. We need to make a line that goes up, 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 some amount. Let's just say that, yeah, why don't we just say a number and we pick it. So from here to, let's hide this. Okay, so the height of this thing, we're just going to choose a number. Okay, let's just choose 80. I mean, what is the big deal? We're literally just trying the first thing. Yeah, so we're going to go to our variable studio, which so then bearing yaw height, let's say this is going to be the outer casing height. This is 80 mils. Okay, so when we're drawing this thing, this is going to be by outer casing height. Okay, great. So we can okay. Or wait, so I think there's a little bit of missing geometry. Oh, because we want a little notch in here? Is that what's happening? Where's that cross section? Why can't I get planes on this thing? Whatever, I don't give a fuck. Ah, so, okay, so that's what's happening. Yeah. We need, right, but the amount that we go in by is important because it basically determines how. So what did I choose? Let's go to that. Oh, so this is wall. Okay, so yeah. So what we did is we went in by wall. Because this and this, are these vertical? So I can go down, but I can't go. Okay. Okay, so let's and I feel like that should be enough, right? We don't need to go in the whole way. Okay, great. So let's just adjust this sketch. And basically it needs to go up 10. So we need to actually oh, what the hell? Oh shit. Okay, so there's this. Is there 2 lines here? Oh no, it's a dimension line. Okay, great. So this is 10. So this needs to go. Wait, what? Oh. Okay, great. So now this needs to be a line. Oh wait. Okay, so this goes to here, and this goes into here, and this becomes wall. Okay, so it's like, so wait, it's like it's like so the bottom one is like this. Okay, I think that makes sense. Is that gonna, okay. So we have 5, we have 10. So wait, let's just make this go up like this, make this vertical. Now the distance between here and here is going to be this by casing. But we need the reverse. So now we need to flip this. Why does this look asymmetrical? Because it is asymmetrical. That's okay. For now, that's okay. We could add a little fillet here. We could just add some fillets just to do a little something. All right. So let's see here. We now need to actually get rid of this thing. Wait, what? I thought I put it in. That was weird. So what actually needs to happen now is, God, I have to draw it out again. I'm being so lame. Oh, what the? Oh my gosh, Windows, bro. Come on, do what I want. So now it needs to be, and then here's the bearing. So here's the bearing, here's the bearing. Then it goes like this. And then this we can make short, right? The advantage of making it long. Well, we could make it long. The reason why we might want to just do this, is there a support benefit? Because we have to think about the printing of this. Okay. So let's delete this. Delete this. Okay, so this goes like out like that. Then up like that. Or actually, let's so then I think like that. And like that. Oh, oops. So this is gonna be okay. So first off, this needs to be 10, right? Okay, we'll just make this 15. Okay, so there's that, but that can't be 6, right? Yeah, so I think it's just this. Wait, oh, is there, right. And this actually needs to be, not that that's ever going to change though, but okay. Cool. So I think we're ready to revolve this, right? So we're going to take this, but not extrude it. Revolve axis. Can I click on that? No, not that. Oh, wait, why can't I select? Wait, that's so weird. Wait, how do I? Wait, how do I revolve it? What if I draw? Okay, wait. What if I do this? Oh, here's what we'll do. Wait, what? Oh, Jesus. Okay. Now we're going to take this revolve, select this axis. Wait, no, yeah, that's good. Okay, so we could do the whole pattern, and we could do the cutout. So I want to do that. So what we're going to do is we're going to sketch on here. Yeah, that sounds good. Why not, right? We're going to make this an M6 hole. And I kind of want to make it more. I just want it like a tiny bit more. But it changes so much, so I don't know. Extrude, remove, up to next. Sir, pattern, part pattern, feature pattern, this extrusion, axis of pattern, this thing, 8. Thanks. All right, so now we need to go about the business of cutting out a notch of 90 degrees. So, and we don't really need to make it the full width of the thing, but we can't make it the gear depth because we need it to be. Yeah, I think I just guessed 25 millimeters. I don't know how, because you want to make it as small as possible, is basically the idea. Okay, so let me just think of a, okay, so we're going to do plane. I'm going to select tangent plane. I'm going to click on here. We're going to flip alignment. Okay, great. Now we're going to go normal. Ugh, this thing bothers me so much. Okay. Okay, so here's what I'm going to do. So I'm going to draw a sketch. I'm going to go back to this sketch. No. This sketch, we're going to draw 2 lines. Okay, but I don't think that this is going to be driven. These two are construction, just like everything in this sketch. But what I want to know is not that, but so let's just get, so we're gonna redo this whole thing. So we need a circle here, and this is going to be something, and I don't know what that something is. It's going to be this. It's going to be, oh, it is. Okay, so that's perfect. So let's go back to the sketch. We can delete this, and we can go back to make our lines. Okay, then we take this, and then I think we should be able to like convert to whatever. So we're just going to copy this. What? Why can't I copy it? Copy sketch. Great. 70.711. Anyways, for what I'm saying is we're going to take this plane, we're going to sketch on it, and we're going to make a, yeah, let's just pick the midpoint for right now. I'm going to make a rectangle. Let's guess again at 20. And then guessing, and then this is not a guess, this is going to be 70.711. I'm going to take this, I'm going to extrude this, remove, and then up to next doesn't work, or through all doesn't work. Oh, through all works, but up to next doesn't work. There's some weird thing about that. Oh, but that works. Up to face works. Okay. Is that what we want? Okay, so now what I want to know is if I take this and I draw a sketch on here. Wait. Why is this being so goofy? Okay, so what I want to know is I want to take this point and draw a line from that point to this point. Did that get on the center? Wait, what? And there should be a line point here. Okay, now what I want to do is make sure that this is a, so it's like almost a right angle. So, I mean, that's close enough for me. 89.999 degrees, like, that's fine. So that's good. So this is just, this is a good sketch. So we just, so let's see. We could rename this to, gear slot is 90 degrees. Great. So what we want to do now is we want to add the feature. Basically, it's a sketch on here. Oh, wait. No, we want the bracket to be its own part. Also, just because I'm a little bit suspicious of this print for no reason at all. I just like checking, I think. All right, seems like it's going fine. But so what we want to do is we're probably going to change the circular pattern to get rid of this hole. We're going to put 2 holes here, and then we're going to design the bracket. Or we're going to have to put it over, and we need to know how far over it needs to go so that the worm drive meshes. But I think that what we can do is just get something down and then change the diameter of the worm as opposed to changing the hole pattern, because reprinting the worm drive is way better than reprinting this. Okay, so now we just got to keep it pushing. So we're going to take this circular pattern. We're just going to 315. Is that right? We want 7. Wait, we want... I don't know how this works. We want 7 over 315. No, I don't think that did what I want. I want... Oh, wait, you know what it was? Wait. Oh, you know what it is? It's not this. It's 360, 8, but then skip instances to skip, and we can just click on this one. That's nice. I like that a lot. Now we are going to sketch on here. And what we want to do is we want to take this, and we want to use it. Well, actually, can we just take the face? Okay. So let's think about this. Okay. Let's take, so this is on there. Ah. Do we get a midpoint? So this is going to be like this. And what we want to do is we want to draw an axis. Yeah, sure. Let's say it's 15. Okay. Now, so what we're saying here is this is going to be the Jesus. Fucking Onshape is such a trash software. This is going to be the center axis of, so what I'm saying is like, take this. This is going to be the center line of the worm. So this is where the teeth start to mesh. But then somewhere in here we basically need a rectangle like this. That's this is going to be stepper width. And wait, what is preventing me from moving it this way? Okay. And then this can be, oops. This is what? I don't know what this is. Is it 50? It can really be whatever. Let's just say stepper height. It doesn't need to go all the way. So what we're going to do is we're going to draw a line. Well, okay. We need to get this down here. And if this, okay, so if this and this, so let's say that midpoint constraint a point. Okay, so let's do, wait. We don't have a distance on there, but we just need to do this. So now we want, yeah, like the distance between here and here. Is that the diagonal distance? Yeah, sure. Let's make it 5. Let's just give it wall. Okay, so now this tells us where we can put our holes. So this is a little unfortunate, right? Is it a little unfortunate? Let me think. Okay, so let's just draw the profile of the line. So it's going to be Q. We're going to dimension this to be wall. Okay. So now we basically have where we can put our holes. I don't really have any problem putting the holes in a weird spot if it just gets us to making this work. Okay, so the first thing that we need to do, first off, this is not construction geometry. This is like real geometry. So we're actually going to take this and we are going to, is that the whole thing? We're going to extrude this as a new body and it's going to be wall. Oh, but okay, why don't we put the whole pattern down? So we're going to take this sketch and we're going to use it for two things. So let's just draw a couple of M6 holes. Should I do 3? Why don't we do 3? I mean, these are inconsequential. That's the thing that I feel like is hard about design and prototyping, is you just need to realize what does not matter. So let's get these vertical, these horizontal. This distance from this is going to be like, and oh wait, you know what we can do? Let's make that 5. This 5. Oh, what? What happened? Oh, wait, is that because of... Wait, if I delete this... If I delete this... No. Oh, because of the midpoint? No, wait, no, that makes no sense whatsoever. Oh, wait. Wait, what is preventing this from being moved? Wait, what? It was what? That was weird. I don't know what that came from. Oh, wait, hold on. We have to think about this. No. What we're going to do is we are going to use threaded inserts there. Because the reason why we need to use threaded inserts there is that we do not want to deal with having this go through wood. Threaded inserts will certainly be strong enough, but I gotta go get my kit, and we need to see what parts we want to use for that. Because, I mean, this does not need to be M6. There's no reason why I picked M6 other than the fact that all the rest were M6. So, yeah, we're just going to use 3 threaded inserts. That's a good idea. I like that. So we just need to change this to be M4. Why not? All right, so we're going to take these 3, extrude, remove, up to next. Okay, but then we're going to go back to this sketch. I'm going to take this and this, and we're going to extrude this new body wall. Okay, great. So now we have the first part. Now we just need to sketch on here, draw a line. Oh, and let's see if I can use my freaking... Oh, I want to use it. Okay, so now we want this to be... Let me just go back to this. 42, stepper width. Yeah, it's stepper width. Okay, now what we're going to do is use NEMA 17 stepper mount. Okay, so this is the face. The part to cut is this, yes. The bottom edge is this. The Y is this. The origin is this. And the Z is this. And then X center from origin, it's going to be stepper width over 2. And the cut depth, that's interesting, but oh, it didn't work. Cannot resolve what entities? Dude, it's right there. What's wrong? Wait, where am I? Oh, it's okay. Hold on. Where's BY? Did I just Okay, let's go back to where I actually used it, which was in here. We're going to go to this. We're going to switch to... Wait, actually... Can I do switch to in a new tab? Whatever. Okay, so I want to look for... Wait, what? I don't see what's failing. Oh, wait, part to cut. Oh, okay, we're good. Hell yeah. That's feature script, baby! That's feature script. That's so hype. Oh, wait, but we want to actually change... we want to, in this extrusion, wait, we want to add, wait, hold on. Wait, how do we want to do this? We could use a use. I'm not like totally against uses. So we're going to sketch on here. We'll take these 3 circles and we're going to use them. And then we're just going to, we're going to make M4 hole. Oh, wait. Typically that it means, okay, so now we just need to do, okay, now we can just, all right. Pretty good, pretty good, pretty good. So we do need to maybe start the assembly, I guess. Let's, so, okay, so first things first, this is clearly too high. So this midpoint thing, so when we select this feature, this sketch, we want to take this thing, which is not that, but this, we want to delete that. So now this can move up and down, right? Okay, move anywhere. Okay, so let's go normal. We definitely want it to be on the midpoint, but we don't want that. So let's think about it, because let's use this. We're going to dimension this from there. So let's say it needs to be, wait, to that? We don't want it to that. We want it to, okay. So this we want to be 5 plus stepper width over 2, I think. Wall plus stepper width over 2. Still, it looks a little high. But maybe it'll work. This is looking good, man. This is looking really good. I'm really happy with how this is starting. So the next steps are definitely to, we could put the bearing in. We could do the bearings. I don't know if I want to do it in the assembly or if I want to do it in here. We definitely want to do the revolve for the inner case, or I don't know what you call it. The inner, the thing that connects to the inner part of the bearing. The top plate. The top plate. Okay, and then what we also want to know is this has a diameter of 110. Oh, diameter of 110, that is totally fine. That is going to be no issue at all. kind of want a snack. All right, let's try to finish this last couple features. I mean, this would be great to just be done with. Okay. Well, let's make an assembly file. So now what we are worried about is basically, okay, so first, oops, what the, how do you undo? There you go. All right, so this, and I think it's just called stepper. Their search is bad on here. Okay, then we want a, let's just use the worm drive that we have right now. So this is worm, oh. I think it's just called tilt worm drive. Okay, so let's get this out here. We're going to take this part. So first off, let's go back here and start renaming things. So we're gonna call this bottom plate. Okay. So okay, and then this UI. Or wait, no. Yeah, that's okay. The bearing yaw. That's what it stands for. Bearing yaw. Okay, so now we want to go. So that center goes to this center. Oh yeah, we want to do this too. And we want to we want to do this to here. Flip it, offset Z22. Pretty sure that's right. No, it's not. What? Why isn't it? Oh wait, let's leave it as it is. Hide it. Click on this and then click on this, and that's wait, it's 19. We want, oh wait, undo. Go back. We want to unhide this, and we want to take this, and we want to modify it to be 19. Okay, perfect. So now, clearly this is too big, and this is too. Okay, so we're going to go back into the sketch, and we're going to need to modify the placement of this thing. Oh, yeah, actually. Right. Okay, now it's all good. This has degrees of freedom, but rotationally. But that's good. Okay, so we're getting there. We're getting there. We just need to honestly, so this is what I was saying is that let's make this thing equal to, we're going to make that height and we're going to change that height. So this needs to be, let's just make this 36. Oh, wait, but to the center? Okay, what's another way to do it? Because we actually want to get rid of this, and we want to make this to here. Yeah, why not? Well, actually, here's what we could do. We can make it as low as possible. Take this to here. Did that implicitly use? That's great. So yeah, so we're going to make this wall. Okay, then we're going to make this 36. Kind of way too big of a window. I think the main thing... So yeah, so that's... Okay, wait, can we go back to the assembly now? So we want to go back here, open a new tab. And we look at this, so what we want to do is we want to basically do a sectional view like this. I'm going to pull this all the way down until we can see. And we got a normal to this thing. Oh, yeah. Yeah, sure, that's fine. But we want to make sure we're normal. Wait, what just happened? So you can see here that this is not even making it nearly that far. So what I'm thinking we're going to need to do is raise this up. And we're going to raise it up by... Let's raise it up by 5 mils, just to start. So we want to go back to the... We want to go back to here. I'm going to look at this extrusion. And we want to make this 2 wall. Yeah, that's a beefy boy. But now we can go back to this and start to see. So now let's we're going to take this, we are going to switch to this, we are going to duplicate it, and this is going to be yaw worm drive. Yeah, worm drive. Yeah. Oh, okay. Yeah. We could do configurations here, but I should get more practice with configurations, but at the moment I just want to, so it was sketch 5, I believe. So we're going to make this, let's just make this big. Let's make this like 40. Oh, that's so weird. I was wondering why it keeps printing strangely. Look at that. That is so bizarre. Wait. Wait, what was the point of that? Okay, I don't know. Okay, so now we need to replace instances of that in the assembly, which I lost, of course. Okay, so we made it bigger. Can we look at that? Dude, I really am... I don't love the way they do that. So now let's just pull it up. Wait, oh wait, okay. So that's good, but now we need to replace this with yaw. Oh wait, can we... I need to go back to this and... But still, like, if we were to... Is that the, Okay, let's, we basically need to keep raising it up. I mean, that's the only solution that I really see here. So we need to go to this. Is it that extrude? 3 times wall. I'm going to look at this now. Did it go up? I think it did go up. I'm wondering how much, because even if we, hold on. Oh wait, there, that's actually... It's still not crossing over though. But we have the option to just make it bigger. So let's do that. So we're gonna make this thing freaking 60. I don't know if this is, I mean, this just feels really, oh wait, we're gonna make it 50. So this feels really icky, but like, yeah, maybe there. Okay, so now that we have proof that, let's see, is there any interference? It's a tight tolerance. That's real tight. Presumably we could just chamfer this. Oh wait, we have to go to this. Wait, actually, that edge, we can just not even do that. There's no reason for that. I'm going to delete this. And we're literally just going to make this... oh, wait. This is so silly. Wait, what just happened? Oh. Wait, what? Wait, did I... What? Look how ridiculous this is. And the crazy part is it's barely... It's barely even going in. So what I'm going to do... Of course, we can make... So just to remember, basically the constraint is that if we... Oh, we can't draw sketches on here. If we were to draw a circle on here, 84, that 84 should touch sort of the middle of this thing. So since we have the room, I'm going to decrease this from 5 to like 2. So we want to go back to here. And then I believe it's... Why is this always the opposite direction of what I think? So if we make this 2... Does that change anything, though? Wait, but what we want... Oh, so this is stupid. This is not what we want. We can just delete this. Or we can just change that. That's actually what we want to do. Okay, so it's... I can tell I'm doing something wrong or suboptimally here, but I don't know. Let's think. So, so if we make this 12, and then leave that the same. Let's go back to here. Okay, see, that's looking pretty good. We can actually make this smaller now. We can make it smaller and we can maybe lower it down a little bit. The unfortunate part is we can't actually lower it down. We can't actually... Okay, so what we're going to do is we're going to make this... Unfortunately, it's only 90 degrees, so I actually don't care. So we're just going to make the slot even bigger. And then we are going to decrease this to 45. Unfortunately, I'm going to have to go back through and figure out what all the gear ratios are, but at the current moment in time, we really can't be... Okay, so we're still actually touching there. So, and then once we have the height, so I'm going to lower this down by maybe 3 or 4. So we're going to go back to here, is it this this extrude? Instead of 15, we're gonna make it 11. Honestly, it's like I deserve to be laughed and mocked at for this behavior, but this is basically all I can figure out. So now what we want to know, now that we have something that seems like it's not interfering. Oh, but it really almost is. We could add a chamfer here. We could add a chamfer there. There's no problem with that. Just to give us a tiny bit more clearance. Honestly, we could just go back and okay, that looks pretty good to me. We could just make this taller. We'll just make that taller. I do kind of wonder if it's going to cave in on itself, though. It doesn't really have much. I mean, whatever. We're gonna find out. If it breaks, it breaks. But like, this looks pretty good to me. We're ready to now design the inner stuff. Okay. Okay, so let's just get started. Basically, we want to sketch on the front plane. We kind of want to hide this stuff. Yeah, these sketches I actually think are a good idea. So we're going to make a line that goes to the bottom here. And it goes up like this. That's pretty much the whole thing, right? Is there anything special? It's just going to be like... Is this the general shape? Oh, it's going to be hard to... Let's look at the cross-section of the original design. It's annoying that you can't click on planes in assemblies. What just happened? What just happened? Hello? Did I just delete something? What is going on here? I'm so confused right now. Why does this one look so good? Wait, why did everything disappear again? Yo, come on, guys. This is so stupid. Okay, whatever. We're just going to go back to this, and we want to just know the cross section. So we want to look at some... Oh. Wait, what? What happened? Oh, my goodness. Wait, what? What did I change? When did it break? Wait. Wait, what? Bearing base pan tilt. I don't know what happened. So that sketch is just freaking broken then, or what? Alright, whatever. I think we can find it. Yeah, so this is it. Oh, but we wanted the top plate to be... Is there any reason to have the top plate be solid like that? Maybe it makes it stronger. We could do that. But yeah, it's this part is actually way simpler. So I had it right. So the only thing that's different is instead of this needs to go to here like this. Okay, so this is going to be, we're going to make this heavy. So we're going to say that's 8. This is 125. This, we can make this heavy too. This is going to be 6. And this needs to be 79/2. So then if we were to do this to this, yeah. Cool. What is left? Oh. Yeah, we want this to here to be, is having no clearance there. Let's make it like 80 points plus like 0.5. I don't know. Is that going to bite me in the ass? I can't even tell. Okay, so the last step, really, well, there's 2 more features now that we have to add, and then this is basically done. We need to add the gear here, and then we need to add the holes here. So can we look at the... Oh, wait. Oh, wait, actually... Hold on. Wait. This should be roughly 80. Oh. Okay. Oh, here's a good look at it. So this is the spacing. So we... Oh, yeah, we should make the bearing, too. And this is 90. So you can see here, it's touching. So presumably we'll be able to decrease this, but I'm not going to decrease it yet. So now what we want to do, well, it'll be kind of an iterative process, because what we're going to do is we're going to add the gear, see how much we can reduce the thing by, the diameter of this by. Then we can go back and see if it fits. And if it fits, we can calculate the helical angle. Then we adjust the spur gear to be helical with that angle. And then we'll be good. And then we can literally print this thing and have a, dude, this is going to be so sick. I know that I'm going to have to reprint this a bunch of times. It's going to be really it's going to be a pain in the butt. But also, look how sick this thing is. This thing is going to look so badass. I'm excited. Okay, so let's get the spur gear on here. So, 10. Okay, we're going to do this 84. So the number of teeth is going to be 42. The module is going to be 2. And the hole is going to be... The board diameter is going to be... $80. No, wait, 80? No, it's, oh, shit. I think it's going to be 70. It's not going to be 70. Whatever we made that wall thickness is, it's going to be, like... But, okay, let's say that the outer diameter of this thing is 80. And the wall was 6. So minus 12. So 80 minus 12. Okay, so now we need to transform by make connectors. So it's going to be this from here to here. Great. Now we need to transform again. And we need to know how far up to translate it. So this is going to be a little bit tricky because we need to know why doesn't it have the red, white, or the red, green, blue? Yeah. So this should be probably at least 30. No, that seems high. 25. 20. Okay, so if we do this, we need to oh wait. Wait, what if I do this? Ooh. Wait, okay. Spurrier second. Okay, great. That's what I wanted. Okay, so first off, it needs to be way higher up. It needs to be, the center line of this thing is going to be like, what is this? What is this edge? This is 11. Okay, it's going to be 12 plus stepper width over 2. So 12 plus SW over 2, which is, I wish you could just pull up a calculator and use all your variables. That would be so nice. You could just pull up a calculator that has access to your variable studio. Anyways, I know it's like 21, so this is going to be like 33. All right, so we're going to move it up 33. We're also going to decrease this to 40. Okay. That might work. That might work. Okay, so we're going to raise up the, so let's make it 33. Or we're going to let's parameterize it. It's going to be 12 millimeters plus stepper width over 2. Okay, and I actually want to make this gear depth. Can we update it? Okay, so I want to make this a depth of maybe 15. Okay, let's just look at it. Okay, now let's do a sectional view from here. Pull it down until we see this. Oh yeah. Oh yeah. Oh, we need to change the mate to Revolut actually. Wait, so okay, let's do this, but then this mate, we want to switch to Revolut. So now if I disable this stupid section view, I should be able to rotate it. Is that intersecting? Can I do like an interference analysis? Where can I see if there's interferences? Really? Okay, cool. How will I know if he really loves me? I say a prayer with every heartbeat. All right. So we are on to something. What I'm gonna do is we're gonna up this again, just by like 2. So okay, so let's go here. We want this section view, and we want to just see how this changes. So we're going to leave this like this. We're going to go over to here. We're going to do this. I'm going to make it 42. We click OK, then we go back to here. And you can see that mesh. It's annoying because you can't really drag. What do we think? That backlash is still kind of tough. Let's see if we can make it 43. This is not engineering. This is me going to clown school. Okay, so now that it's at 43, we want to do this. We want to go to, this is the same, and then this is 43. So now we just need to go back to this, copy this, and we want to go to this spur gear. We want to say it's helical, and we want to make the degrees this. Oh, and we need to check that it's actually the right helix direction. Oh yeah, printing this is actually going to be lame as hell. Whatever, we'll just do it with supports. Okay, so how do I know if it's right? I don't. Well, let me flip it around and see if it looks even worse. Wait, it's hard for me to tell. Okay, so this... I feel like this might be right. Okay, hold on. So this angle is looping around this way. It's going up this way. I feel like this is right. Yeah, because these are like this. And so are these. The angle looks a little steep, to be honest, but Okay. All right, hole pattern, and we're ready to do our first test print of the bearing design. I'm sure there's a ton of things wrong, but I'm excited to print it out. This has been a long time in the making. A long time in the making. Okay, so the last melon, the last step. We need to copy the whole pattern. We need to take this and we need to just copy all of the holes. Dude, I've been only streaming for 2.5 hours. It's 2:45. That's crazy. I feel like we got so much done. This thing is so sick. Okay, wait. So let's switch to... Now we just want to look at this sketch. I want to copy sketch. Copy sketch. Now what we're going to do... Paste sketch. Okay, wait. But... Yes. Wait, no. Wait. Damn it. Oh, okay, wait, hold on. Let's see if we can do this. That's to the closer one. Is that in there? Wait, so is this fully solved? Okay, sick. Wait, what? Oh, I see what happened. Let's take some measurements. Now, what am I thinking of? I feel like this looks like a logo. Okay. So now let's get the other ones. So we're going to take this sketch. I'm going to copy sketch. You can't copy. Oh, wait, hold on. Copy sketch. Paste sketch. Wait, what? Wait, what is this? Okay, never mind. We're just gonna do it. Wait, there's this. Okay, we're not gonna do this. Wait, what? We're just going to make one of them. Okay. What a crazy sketch. Okay. We only need... What is that? That's driven? No, okay. That's nothing. Okay, so it's 174. I think the only thing that changes is... Is that. So wait. So it's the same distances. That's why, yeah, these are all concentric. There's 2 layers of concentric holes. I get it. Okay. So wait, so let's just, I just want to keep that open though. This monstrosity of a sketch. Oh, this is duplicate. Okay. So we're going here. We're making circle and a circle. This distance, wait, is this thing. These are... Is that it? Is that for real it? Oh, nice. Well, I guess we could do the reassembly and try to figure it out. Does that look right? Let's just look at them side by side. I can't hide this timeline. That looks pretty similar. Cool. Assembly is actually going to be so much easier. Dude, fixing stuff to the top of this is going to be easy now. That's going to be great. I'm really excited for that. Okay. Oh, let's put the bearings in. So I'm just gonna do this. Fuck yeah. So now Only took me way too long to design this because I was being a little scaredy cat. All right. I'm pretty happy with that. Let's see. What else should I do? Maybe I'll hop on again later, but I feel like that's it. Oh yeah, so we need this part printed, this part. We need all of this printed. So this is going to be like a jolly old time. I feel like this angle looks a little steep, no? In any case, we did it. Honestly, I want to make that thinner. So we just need to go to I mean, should we just take a look at how long this stuff is going to take to print? I feel like that's a good idea. So, okay, so here's what we need to do. We need to take this bracket, this, this, and this. We need to export by four hours. Yeah, the bottom plate will need supports. Okay, so let's just for bottom plate enable supports and see what it does. Because we'll probably paint some features out. Like if it's gonna make a big cone around this whole thing, like exactly. Like I don't think that's necessary. That's gonna be a pain in the butt. Pop all that out. Maybe I'll just listen to it for once. Alright, so we have 10 hours of printing ahead of us. I'm excited. And we got a massive assembly day. Probably can't even do it tomorrow because, well, let's see. This is going to be done in an hour and a half. It's 4 p.m. It'll be 5. Okay, tomorrow I might be able to print all this. I'm going to go check how much filament I have left. All right. I'll be back in a sec. Okay, I'm happy with that stream.